Hey, welcome back. We're going to do number 3. This is actually exercise 42 and 44 at the end of section 3.4. And our goal is to graph the polynomial functions. We're supposed to graph by hand, and we're going to combine the intercepts, both x and y, the multiplicity, and the end behavior. So let's start with 42. With 42, what I want to start off with is the y-intercept. And with the y-intercept, the input is 0. And if you put in 0, you get 0 plus 3 squared times 0 minus 2. And this is going to be a 9 times negative 2, or negative 18. So I could make a chart over here with some x and y information. The y-intercept is negative 18. And let's now figure out the x-intercepts. The x-intercepts, we want to solve f of x equals 0, because for an x-intercept, it's the output that's 0. And so this just means that either x plus 3 is 0, or x minus 2 is 0. And so that's negative 3 and positive 2. So negative 3 and positive 2, those will be x-intercepts. And I want to point out that the multiplicity is 2 for negative 3 because of that factor, that exponent of 2, but the multiplicity for positive 2 is just 1. So that's a simple root. Let's erase some things and get some more space. Okay. And so we have the x and y intercepts and the multiplicity. And let's just go to the end behavior. The end behavior, what we need is the leading term. Leading term. We can imagine that we're going to multiply out this polynomial and put it into general form. So we'll multiply it out, collect like terms, and sort them from the highest degree to the lowest degree. But if we just want the leading term, then we don't need to do all of that work. We can see that the leading term is from the leading terms of each of these factors. There's x plus 3 squared times x minus 2. So we're going to have x times x times x is x cubed, and the coefficient is 1. And so the end behavior, as x goes to positive infinity or negative infinity, that's called the end behavior. You can see that it's an odd degree polynomial with a positive coefficient. So as x goes to infinity, the function goes to infinity. And as x goes to negative infinity, the function goes to negative infinity. And let's do some erasing and just put everything together into one graph. Okay, so here's the graph. It's just going to be a sketch. It's going to be a pretty good sketch, but the end behavior looks like this. It's going to go either to the right or left. It goes up or down. The intercepts negative 3 and positive 2. I'm not going to be too careful about where I place these, but they're roughly correct. With multiplicity 2, that means that it's going to look like a parabola near negative 3. And with multiplicity 1 at the 0, 2, it's going to look like a straight line. And so those are the pieces. We just have to connect them because it's a continuous and smooth function, and it's going to look something like this. So there it is. It's a cubic that looks roughly like that, and that's at least a decent sketch. Okay. Let's pause, let's erase this, and take a look at the next one. Okay, another possibility, another function, and we're going to work on this one. So let's first do the y-intercept. We want f of 0. That's going to be negative 1 cubed times 3 squared, and that's negative 9. And I can just drop that into an xy chart. So 0, negative 9, that's the y-intercept. And for the x-intercepts, we want to solve f of x equals 0 because we want the output to be 0. And in this case, since it's already factored, you can see that x equals 1 and x equals -3 are those two factors, are those two zeros. And the exponents tell you the multiplicity, so that 1 has multiplicity 3 and -3 has multiplicity 2. And now let's look at end behavior. For that, we need the leading term. The leading term is just going to be, imagine that you multiply it out and collect like terms and put them into general form, so organize them from the highest degree to the smallest degree. But we don't need to do all that work. We have f of x is x minus 3 cubed times x plus 3 squared. If you imagine multiplying this out, this first factor, you'd have x cubed plus a lower order stuff. And that stuff is never going to multiply to give a higher order exponent. And then the next factor will be x squared plus smaller stuff. And together, that's going to give you x to the 3 plus 2 plus stuff. So the leading term is 1 times x to the 5th. And that's enough to tell us the end behavior, because we want to know what happens as x goes to infinity and what happens as x goes to negative infinity. Well, we have an odd degree polynomial, 5 is odd, and a positive coefficient, so that means that as x gets really big, the leading term will dominate. It's 1 times a very high power of a big number, that's infinity. But as x goes to negative infinity or a negative big number to an odd power is negative, so it's going to go off to negative infinity. So that's the information. That's enough to give a nice sketch of this. Let's erase and sketch out what this function looks like. Okay. So putting this all together, just do a bad sketch. First, the end behavior. As x goes to the right, we go off to infinity, and negative infinity as x goes to the left. The y-intercept is at -9. At 1, there's a 0, and at -3, there's a 0. And at 1, the multiplicity is 3, so it actually looks like a cubic there. And at -3, as multiplicity 2, it looks like a parabola there, a quadratic function, and it goes through -9. And so if I sketch this, it's going to look somehow like this. And that's a rough sketch, but it does capture the end behavior, the intercepts, and the multiplicity. So that's it. Let's stop number 3 here, and we'll go on to number 4.